Hello and welcome to our presentation. This is Group 3 and I am Tini Ichikel.
I am Jeremiah Elijah.
And we are going to present about pharmacognosy of Cinchona bark. Outline. Our presentation will cover the following. 1. Introduction to Cinchona bark. Cinchona is a genus of flowering plants in the family Rubiaceae containing at least 23 species of trees and shrubs. All are native to the tropical Andean forests of western South America. Cinchona bark is also known as Peruvian bark or Jesuit's bark. It is famous in its medicinal properties, traditionally used by indigenous populations to treat fevers. Cinchona bark was introduced to Europe in the 17th century and rapidly became the cornerstone of anti-malarial therapy. Cinchona plants are large foliage growing 5 to 15 meter, 16 to 49 feet in height. The shrubs or small trees with evergreen leaves are opposite, rounded to lanceolate and 10 to 40 centimeter long. The flowers are white, pink or red and produce in terminal panicles. The capsules containing numerous fruit is a small seed. As you can see here in figure 1 shows the fruit and flowers of Cinchona. The key character of the genus is that the flowers have marginally early corolla lobes. Some species display heterocoely. 2. History. The febrifugal properties of bark from trees now known to be in the genus Cinchona were used by many South American cultures prior to European contact. It is known that the bark was first used as an antibiotic in 1630 by Jesuits, although it was discovered in 1513 in Peru. The traditional story connecting Cinchona species with malaria treatment was first recorded by Italian physician Sebastiano Bado in 1663. Owing to the efforts of Viceroy of Peru, Count Cinchona, and was introduced as a drug in Europe around 1655. Quina bark was mentioned by Fray Antonio de la Calanchia in 1638 as coming from a tree in Loja. He noted that bark powder weighing about 2 quints was cast into water and drunk to cure fevers and tetrains. Figure 2 here shows the bark of Cinchona. The bark was included as Cortex Perionis in the London Pharmacopoeia in 1677. 3. Taxonomic classification. The taxonomic classification for genus Cinchona are as follows: Kingdom, Plantae, Phylum, Tracheobionta, Class, Mengioliopsida, Order, Gentianalis, Family, Rubiaceae, Genus Cinchona Hel, Species Cinchona officinalis. 4. Distribution. Cinchona species are native to the tropical regions of South America, particularly along the Andes Mountains in countries such as Peru, Ecuador, Colombia, and Bolivia. Cinchona trees typically grow at elevations between 1,000 and 3,000 meters above sea level, where environmental conditions such as temperature and humidity are optimal for growth and alkaloid production. The plant thrives in tropical and subtropical climates with high annual rainfall around 1,500 to 2,000 mm, moderate temperature around 10 degrees Celsius to 25 degrees Celsius, and high humidity. These climatic factors are essential for both growth and accumulation of active constituents like quinine.
5. Chemical composition of Cinchona bark. Alkaloids are considerable chemical constituents of Cinchona. Cinchona bark containing about 30 types of alkaloids, which belongs to quinoline group. The important alkaloids of cinchona bark is quinidine, quinine, cinchonina, and cinchonidine. Methoxy group like quinidine and quinine is present, but no methoxy group like cinchonine and cinchonidine is present. Starch grains and beta-glycosides is also present in cinchona. The cinchona contains 30 to 60% of quinine alkaloids. 6. Therapeutic uses of cinchona bark. Traditional uses of cinchona bark. Cinchona bark was first documented in Spain 1630 for fever treatment, later identified as effective against malaria parasites. Its discovery of quinine extraction marked a milestone in herbal medicine. The Madras Cinchona Commission 1866 to 1868 studies 2,472 malaria cases, trialing quinine, quinidine, cinchonine, and cinchonidine. Quinine became the most widely used alkaloid after 1890 due to superior efficacy. Modern uses of cinchona bark. Quinine from the cinchona bark remains clinically and industrially relevant, serving as an anti-malarial flavoring agent, muscle relaxant, hemorrhoid and oxytocin treatment, while also showing experimental potential in cancer therapy through inhibition of cell proliferation and induction of apoptosis. Quinidine, a key alkaloid in cinchona bark, is clinically important as an anti-arrhythmic agent used to treat atrial flutter, fibrillation, tachycardia, and premature atrial contractions by stabilizing cardiac cell membranes and altering sodium influx. Cinchonine, a less toxic alkaloid than quinine, shows strong anti-malarial and antimicrobial activity. Is applied in conditions like amoebiasis, flu, dysentery, and fever. Acts as a mild gastric stimulant and demonstrate experimental anti-obesity effects by suppressing adipogenesis pathways. Cinchonidine, a stereoisomer of cinchonine, serves mainly as a backup anti-malarial in resource-limited settings, but despite declining use due to toxicity, cinchona alkaloids remain significant with expanding applications in arrhythmia management, antimicrobial therapy, cancer treatment, and metabolic disorders. 7. Significant pharmaceutical information of cinchona bark. Historical pharmaceutical significance of cinchona bark. Cinchona bark was the first effective treatment for malaria, discovered in the 17th century. Quinine, its most famous alkaloid, became the cornerstone of anti-malarial therapy before synthetic drugs were developed. Modern pharmaceutical significance of cinchona bark. Quinine derivatives are still used in resistant malaria cases, though artemisinin-based therapies dominate today. Quinidine remains clinically relevant for certain heart rhythm disorders. Research continues into secondary effects, anti-inflammatory, metabolic regulation, showing potential beyond malaria. 8. Summary. Cinchona bark is used as first effective anti-malarial treatment. Quinine became the cornerstone of malaria therapy. Contains approximately 30 alkaloids. The 4 important alkaloids of cinchona bark are 1. Quinine, 2. Quinidine, 3. Cinchonine, and 4. Cinchonidine. Traditionally, it was used for fever remedy. Modern application in malaria, cardiac arrhythmias, antimicrobial therapy, cancer research, and metabolic disorders. 9. Acknowledgement. We acknowledge the following who have supported us to complete this assignment. 1. Dr. M. Yaimbu for supervision. 2. Professor Philip Kigodi for the PowerPoint presentation. 3. Others including all the relevant sources that are referenced here. 10. References. That is all. Thank you for your time and attention.